Hey, what's going on, guys? Let's do this problem right here. We have an airplane flying on the top, and we have the pressure on the wing, right? The on top of the wing and the bottom of the wing. And this is the picture of that wing. And if you see that this is the air molecule. So by this wing, this air molecule is going to be separated into two parts. So on the top, we are going to have greater velocity, and in the bottom, we are going to have the lesser than the top velocity. So it's designed in such a way it possible to happen this way. And the question is asking what is the pressure that's going to be acting on the plane if it was like this. So let's see how we can do this. We are going to apply Bernoulli's equation to find this one, because we have to find the pressure, right? We know the area. P is equal to F over A. F is equal to P times A. So this is delta P, pressure change, times the area. We know the area, that is 50 meters square. So each wing has 50 meters square area. So this is going to be 100 total, but we have to calculate the pressure difference. So let's calculate that one. So let's use the Bernoulli equation. So I'm using the pressure equation. So let's use the pressure equation. So that's going to be P1 plus rho G H1 plus half rho V1 square. That is equal to P2 half P2 rho G H2 plus half rho V2 square. If you look at this wing, bottom and top, it's like same height, right? So we can cancel these two, and we are left with this one right here. So we have to calculate P2 minus P1, because when the velocity is going to be high, when the velocity is high, pressure is going to be low at that point. So on the top we are going to have low pressure. So V1 is going to be low, 2 is going to be bigger. So we have to deduct P2 minus P1. So let's deduct P2 minus P1, right? P2 minus P1, that's going to be equal to half rho V1 square minus half rho V2 square. We can take half rho common. So half rho common, that's going to give us V1 square minus V2 square. So let's calculate these values. Half, and then density of the air in the atmospheric pressure, like in the atmosphere, is usually 1.29 kilogram per meter cube times this velocity. So we know that V1 is, so we are taking the 1 as top, V1 is top, V2. So V1 is 179 meter per second square minus V2, that is 134 meter per second square, and that gives the value of 9085 Newton per meter square. So this is the pressure difference, P2 minus P1. So that's delta P, right? That delta P is P2 minus P1. So we have calculated the delta P. So we can now calculate the force. So let's calculate the force. Maybe we should use different color. So F is equal to delta P times area. Delta P is 9085 Newton per meter square, and we know the area of one wing is 50 meters square. So when we add two wings together, that's going to be 100 meters square. So meter square cancels, and we will be left with 908,500 Newton, and that is the force that's going to be acting on the bottom. And if you calculate this, so W is equal to mg right here. We know this is 5,000 kilogram, and G is like 9.81. Roughly, if you take 10, it's going to be 50,000 Newton. So it's like this is far bigger than that. So we know this is capable of flying due to this velocity and pressure, right? So that's how we calculate these things. I hope you guys like this video. See you next time.